let's talk about these two things. I'm going to color code. I totally forgot to do this on the last set of notes. I'm kind of trying something new this triad. So one of them, the first one is going to be the red square, and the second one is going to be the blue square, and we'll put those down in the notes. If you want to put the red square and the blue square so you can kind of track, because remember, I'm going to have a learning log out next week so that you can kind of match up what these are, where these are, what these go within the learning log, okay? So this word here is logarithmic, and this word is exponential, okay? All right, so on the count of 3, we're going to read the red square together, all right? So 1, 2, 3.
An equation from logarithmic form to exponential form.
Okay, so probably we don't know any words in there except for equation. We started working with exponentials. We know that that is some number to a power, or an e, which is a new number to us, and a power, okay? All right, so on the count of 3, we're going to read the blue one now. Are you ready? I'm going to hear everybody this time. 1, 2, 3. Awesome, good job. So just like we have algebraic properties, we've talked about them a lot with exponents this year. We have a set of properties that we can apply to something called logarithms, all right? So if your parents have nightmares about Algebra 2, this is probably one of the things that they remember having nightmares about. Logarithms is very unique to the Algebra 2 course. You have never, ever seen this before. You saw exponentials in Algebra 1 a little bit, but you never saw logarithms, okay? So it's kind of nice that it's new because it's interesting to learn something new. This goes really, really quick, so you got to make sure that if you don't understand something that you're asking, okay? So we're going to try this out. We should finish this set of notes pretty easily today because it's not hard stuff. It's just we're manipulating a lot, okay? All right, so a logarithmic function with base a, okay, is f of x equals log base a of x. So just like when we talk about an exponential, we call this the base, okay, and you're going to see that these things are going to be interchangeable. The log has a subscript on it, so it should be written a little bit lower, not like an exponent. It should be written a little bit lower, and that's the base of the exponent, okay, or the base of the log. So we read that, the way we read it is log base a of x. That's how we say it. Usually that a is going to be a number. Log base 2 of x, log base 3 of x, log base 10 of x. All right. We're going to write down the log loop right here. And I call it the log loop. I know Mrs. Rondeau calls it the swirly. Okay. I call it the log loop because that's what I remember when I took Algebra 2 in high school. That's what my teacher called it. Okay. So if we have log base a of x and it's equal to y. So if we have that equation, we are allowed to take that log equation and convert it into what we call an exponential equation. So it's equivalent to a to the x equals y. So what happens is this is the base. So it becomes the base becomes the big number. And then we swap where I wrote it down wrong. It's not x, it's y equals x. So a to the y equals x. And then we switch these around. We're looping them around. That's why I call it the log loop. Because it's logs and we're looping. Thank you. Okay. So if you see, and all a logarithm is first of all, it's a decimal number. It's also a way to manipulate exponents. Okay. So that's why we have logarithms. You're going to see, if you've been taking chemistry, you may have seen them already. Okay. So we're going to teach you the algebraic piece behind what you've been seeing in chemistry. You probably have just been pushing buttons on calculators, right, with a logarithm. So we're going to see the algebra piece of it. Okay. And it's going to take us all the way through break, probably, to get through all of this. Okay. All right. If you see a log written out without a base, then a equals 10. So if you just see like log x, we assume the base is 10. We work in a base 10 world. Okay. There's another log function It's called the natural log. All right. So it's a function where it's the base is e. But this function is so special that it actually has its own name. It's lnx. And that actually doesn't stand for log natural. It's actually the initials of the mathematician that invented it, because it was invented by Louis Napier. So, yeah. So if you go ahead and you invent a theorem, you can name it after yourself. So lnx, that's an L, a cursive L. Okay, because watch what happens. Okay, so this is a big deal. Okay, because this happens every year. I don't know what happened to fusion. If I write it like this, doesn't it look like a 1n? So if I write it like that, I have kids on quizzes doing this. That's not. Yeah. So that's why I write the cursive. My L's are always cursive. Okay, so it's LN. All right. All right. So if we have, so this is kind of a property right here, the natural log of x equals y, we're going to consider that base e, and we can do the loop on that. We would have e to the y equals x. We see the looping more on the common log, which is the log base a, than the natural log. Okay. All right. So as far as our I can statements go, okay, we're going to work with the red square one first. So this is the red square. Okay, so all of these problems from here till we get to the next set of problems are the red square problems. Okay. The instructions say write the logarithmic equation in exponential form. So it's in log form. I got to convert it to exponential. Okay. All of these properties that we're manipulating today and in the next lesson are going to help us eventually solve equations with these. Okay. So we're just learning a lot of this property stuff. All right. So what is the base of this first equation right here? What did we say the base is at? Yeah, good. It's the 7, right? It's the A part of it. So the 7 is the base. Okay. Yeah, it's only if it does. There's nothing written there. That's right. It's 10. Okay. All right. So it has just a 7. And now I'm going to loop it around. This is the log looping part. So my 2 is going to become my exponent, and it is going to equal the number 49. Look at that statement that we just wrote. Isn't that a true statement? Isn't 7 squared equal to 49? So this is another way to write something like that. Okay, it's a way to manipulate an exponential. All right, because again, it helps us solve equations later on. Okay, all right. Looking at example 2. All right. Actually, I want you. Let's do example 3, and then I'll have you do example 2. Okay. What is on example 3? What's the base? 4. Good. So I'm going to loop this around. What's my new exponent become? -3, and it's going to equal this number 1 over 64. Well, doesn't -3 mean I have to move the number down? I'm just saying it would mean move it downstairs, right? And what's 4 cubed? So is it a true statement? Yeah, it's still a true statement. You don't need to write any of that part. You just need to write the loop part. All right, everybody try example 2 before we do the one with the natural log. And it's hard to tell that you're actually doing work on these, right? Because it's one line. All right, what's the base? 5. What's my new exponent? 3 equals 125. Okay. All right, let's do number 4 now. So natural log, the base is assumed to be an e. Okay, so I'm going to squeeze a little e in there. So my base is e, and then I'm going to do the same looping around. I can't really eyeball check it because I would need a calculator to deal with that. But so we're going to have this goofy decimal point, 147 ... 147 ... equals 2. So if I put that in my calculator, it would be equal to 2. I'm not going to worry about putting in. Again, I want you to make sure you can loop the common log ones. The e's, they get manipulated a different way, usually. All right, any questions on looping that way? If I can go forwards, I can go backwards, though, can I? Okay, so these are still the red squares. Okay. All right. So now look at the instructions. It says it's an exponential equation. Write it in log form. All right, so I'm going to put it back into logs. So I've got log. I got to find the base. Remember, the base is that first number with the exponent on it. So what's the base? 9, and then I'm going to loop the exponent and the number. So log base 9 of 3 equals 1/2. The opposite of what I did before. But I'm still looping, right? I'm still log looping. All right. I want you to try 6. So everybody try 6. Figure out your base and then swap the location of your exponent and the number. Okay. What's the base? 4. And then I'm going to swap this location. So log base 4 of what number? 16 equals 2. Okay. And that one, we really can't eyeball check those, right? Because we don't have a concept of what that is, but that's what it looks like. Any questions on the looping thing? All right. These are going to be a little bit different because they're natural logs, okay? Because they're e's, all right? So I'm going to write it I'm going to kind of start it the same way. What is my base technically? E. So let's write it log base E. There's nothing that says we can't do that. And then I'm going to write this goofy looking number, 148.413 ... equals what? 5. Good. But we can get a little fancier because we know that log base E is the same as natural log. So I could write it as ln 148.413 ... equals 5. Okay. Take a couple of seconds, like 40 seconds. Try example 8. Okay, what's the base? E, good. Okay. And then what number gets written on the inside? Yep. ... equals what number? 2.5. And then our fancy way to write log base E is natural log, right? ln. And you can just say natural log. We all know that natural log, we're going to write ln. Okay, that's the language we use, right? Okay, any questions about the looping piece? Okay. This part here was not in our I can statements, but you need to know how to do it. Okay. We're going to practice putting these in Desmos really quick. Okay. On how to evaluate this using a calculator. Because at some point you might have to, I'm guessing in chemistry, you have to evaluate these. Okay. So, I'm going to rewrite. So it says we gave us 4 different numbers to plug into this function. So I'm going to use my good function notation and I'm going to say f of, I'm not writing very well, f of 10 equals log base 10 of 10. So I'm substituting in for the x, just like I would in any other algebraic equation. I'm going to go to my calculator and find a number. All right, so give you a couple seconds to write that, and then we're going to everybody open a Desmos tab. You need to do this with me. Okay. All right, so I'm going to Desmos. Doesn't matter if you use Desmos Graphing or Scientific. Remember, if you don't want to type that in, you can go to Google Classroom. The links for all the Desmos calculators are there. Okay. All right, so there's a couple of ways that you could deal with this. All right. So you could just start typing it the way it looks, log. Okay. But then we have to deal with the subscript and the superscript. So we all know superscript is shift 6, right? You need shift underscore. So shift the dash next to the 0. It should move it down, I think. Did that work? Okay. And then what you don't want to put that second 10 down low, you got to arrow a little bit and make the cursor big. See how I made the cursor big? And then 10. Okay. Let me show you another way to do the same thing. Okay, so if that didn't work for you and you didn't remember to do the shift underscore, right? You can come down here to the keyboard. It drives me crazy to hit these buttons. That's why I always find the shortcuts. And then if you look here under functions, there's log and natural log and log base A. So you would just grab the log base A. Oh, we put nice parentheses there for you. The 10 and the 10. Okay, so it's your choice. You pick how you want to do it. I like shortcuts. All right, so my answer was just 1, right? Okay, so equals 1. All right, so the next one here on B, we're going to use proper function notation. So I'm going to write f of 2.5 equals log, and notice my base is still the same, log base 10 of 2.5. And we're going to figure out what that's equal to. And I'm going to show you one other thing on the Desmos here while we're in there. Okay, so I'm going to clear out the 2 that I got. All right, and I'm going to do log, and I'm going to do shift 6 or shift underscore 10, and then it was what, 2.5? Okay. Now, remember how we said that it's a log, if I don't write anything on it, it's assumed to be base 10? So try just typing log 2.5. We got the same thing, right? Okay, so you got to be careful. It has to be log base 10 for that to work. If it was log base, let's try, I'm just going to put something else in so that you can see that it's not, you have to type the subscript. So if I did log base 2 of 2.5, notice it's a different number. So you got to really watch what your subscript is, okay? All right. I want you to try both C and D on your own. You can put 1/4 or you can put 0.25. I don't care. Okay, so try C and D, set up the nice function notation, try putting those in your calculator. Yeah, I need your ID.
127.
127.
267.
Okay, go ahead. Okay, let's check your answers. All right. Something goofy happened on one of them, right? Okay. It was supposed to happen, just so you know. So you didn't do anything wrong. All right, I'm going to take the shortcut and just do log of -2. Notice it came up undefined. Okay. Let me explain why. Let's look at just the graph of a logarithm. Y equals log of x. Look at what the graph looks like. Is there anything over here at -2? No. Okay. Notice there's nothing over here. Unless I shift that, right? Like I can shift any other graph. There's nothing going to be inside a negative. So really when you can't really have a negative inside a logarithm. It's going to come up undefined. Let's write that down. Okay. Because that comes up a few times. So one thing we have to be careful of is no negative number inside a log. It's okay for your answer to come out negative, but that number inside cannot be a negative number. So like when we're solving equations, we get negative numbers sometimes. We just can't have a negative that gets put back inside. All right, let's look at log base 10 of 1/4. So let me try that one. Log of 1/4. Do we agree? Negative 0.602. Everybody okay with that? Yep. And that's okay. We got a negative answer, right? It's just the number inside can't be negative. All right, so negative 0.602. 3 decimal places, right? Okay, are we good with where we're at now? Any questions on calculator? All right, so our first I can statement was we can apply the exponential in the logarithmic form and go backwards and forwards and do what Mrs. Ballard calls the log loop. Okay. Our second I can statement is we're going to apply the properties of the logarithms. Okay. So that's from here on is going to be the blue square. Oh, that's not a blue square. That's a purple square. It's going to be the blue square problems from here on. Okay. So these are all going to be properties of logarithms. Except for, of course, there's some calculator ones that sneak in there, aren't there? Oh, it says without using your calculator. Okay, yeah, those are properties ones. Okay, so we're going to write down what the properties are, all right? And there's some really nice things that go on here, okay? So when I have log base A of 1, that's equal to 0. So if I have log of any base and the 1 is on the inside, that's a 0, okay? when I have log base A of A, that's equal to 1. We actually proved that, didn't we? Look it up here. Didn't we do that? Log base 10 of 10 equaled 1. So no matter, as long as those numbers match, it's equal to 1. Okay. Then if we have log base A of x, it's equal to x. Basically, if this and this match, I get whatever the exponent is, because isn't that what happened here? The exponent was 1 on that one. Okay. So if the base and the number inside the log are the same, we don't want to say it cancels. We feel like it cancels. That's what we kind of think. But we really have that it's equal to the exponent. Okay. And then the same thing happens here. This is written really terribly. It should be log base. This should be a subscript. It's not written like a very good subscript right there. It should be log base A of x. If I, again, the A is next to the A, right? The A is next to the log base A. We get whatever's inside. So it would just be equal to x. And then the next one is ridiculously easy, and we forget about it all the time. Okay. If I have that two logs are equal and they have the same base, that implies that the insides are equal to one another. Basically, I can kind of cancel those logs and I put the insides equal. And usually it turns into like an algebra 1 problem. At the most, it turns into a quadratic and we've got to do our quadratic factoring and stuff. But usually it's a simple algebra 1 problem inside. All of these same properties, look at the blue box. They all are the same for natural logs, okay? This is a big one right here, okay? We use that one. It's an expected memorized for the AP Calc exam. So you need to know that natural log of 1 equals 0. We'll probably work on that more next year, okay? But that's one, if you get it down now, it's one less thing for next year. But the same thing, natural log and E, basically they're best friends. And they really don't, but we say they cancel each other out. Because look at, I got an exponent of 1, I got an exponent of x. If the E and the natural log are together, I get the whatever's on the inside. Okay. Any questions on properties? Let's put them to use. They're more helpful when we can put them to use. All right, so in these ones, it says we're going to evaluate the function at the indicated value of x without using our calculator. Okay. We're going to use exponent properties to help us. All right. So I'm going to, when we evaluate, it says, hey, that means we're going to plug that 8 in for the x. So we've got f of 8 equals log base 2 of 8. So first thing, remember when I have that f of 8, it's just telling me I'm taking 8 and substituting it into the function. It does nothing to do with the calculation. It's just notation. Okay. My goal is to get a number, not a log, a number. Okay, so remember one of our properties was that if this base matches this number, I can cancel it out and get the exponent. All right, is there another name we have for 8? It's 2 cubed. Check that out. Did I get the base and the number inside the log to match? Yeah. So we're going to use the terminology cancel. Okay, so it cancels. What's left? 3. Like, it's ridiculously easy. Okay, there's a lot to it, but it's ridiculously easy looking algebra. Okay. All right. I want you to try the one with 81. See if you can figure it out. Okay, you're going to use the same process we just did on example 10. Everybody try it. Okay, I want you to check it with somebody at your table. You're struggling with the 3 we know we need a 3 there, right? So check it with somebody at your table real quick. Okay, let's check it together. we know where we want to force this base to be the same as this, right? So we want it to be log base 3 of 3. So what's another name for 81? 3 to the 4th. What happens with the log base 3 of 3 then? Cancels, and what's left behind? 4. So your answer is 4. Okay, any questions on that? Okay, it's one way to apply the properties. Now we're going to solve some equations using the properties. This first one, please, if you see this on a test, do not get it wrong. Okay, let's go back up and look at our properties again. I'm going to show you which one this is. This is this one right here. Okay, this one said if my bases are the same, the insides are equal. So if I have one log on each side with the same base, it looks like the logs cancel and the insides are equal. Do I have a log with the same base on each side? And a single one, and I'm emphasizing that because it changes later on. Okay, a single log on each side with the same base. So basically those cancel. What's this? X equals what? 5. We could go back to rational expressions if you guys want. I think this is way nicer than that stuff. So, all right, look at example 13. Here comes our little quadratic thing. Okay, so what happens? Do we have a single log on each side with the bases the same? Yes. Okay, so basically we say they cancel, but that's only going to be used the terminology we use in Mrs. Ballard's class. Okay, so we're going to say x squared minus 6 equals 10, because what we had on example 12 was way too easy, right? I have to solve that. What am I going to do next? Add 6. So x squared equals, when I add 6 to 10, what do I get? 16. All right, how do we undo the square? Square root, what do we write in front when we take a square root? Plus or minus. So x equals plus or minus, what's the square root of 16? 4. Okay. All right, before I do any more, I want you to try example 14. It's identical to 13. Okay, I just changed the numbers. Okay, check it with somebody at your table real quick. Okay, do I have a single log with the same base on each side? What do we say happens? Cancels. All right, so x squared minus 5 equals 20. Now what? Add 5. It's doing this really weird delay thing today. All right, so we're going to add 5. What's 20 plus 5? 25. How do I undo square? What has to go in front? So x equals plus or minus 5. Okay. Any questions on that particular property? Because we're going to move on to a different property next. Okay. All right. This one is very similar to what we did up here. Okay. Similar. So this time, but we have it equal to x. What happens when we have a log with a base and a number here that match? We're going to say in Mrs. Ballard's class that's called canceling, right? So we're canceling that. What's the only thing left? 2 equals x. So we're going to look, when we're doing log problems, we're going to look for opportunities to create that for ourselves, right? All right. Look at the next one. I don't know what happened there. This should be an x, not a 5. That's what happened. So edit Mrs. Ballard's notes. Make that an x. Okay. This is probably on the extra page, right, that I handed out today. All right, everybody do that one. It's just like the last one. Everybody try it. All right, what happens with log base 4 of 4? Cancels. So 5 equals x. Okay. And it looks like we almost did nothing, right? Because it's one line. Why did I give you that much space? I don't know. Okay, because we didn't need that much space. All right, so those ones were equations, right? Equations means we have an equal sign. Notice now we're moving on to expressions. We're going to use the properties of logarithms to basically simplify the expression as simple as we can possibly get it. So there's no equal sign on this one. Okay. All right, so looking at 17, we have log base 2 of 2. What happens? Cancels. What's the only thing left? 5x. Perfect. All right. 18 is not as pretty. Okay. In order for us to do this thing, the number has to be in the numerator. Okay. Do you see how we have the number, but it's not upstairs? So, and this is something that's really important for us to get down, that we can use this exponent property to manipulate algebra for us. Technically, what exponent is on that 3 that's in the denominator? 1. There's always a 1, right? So in order to move this up, one of our exponent properties says we're allowed to make the exponent negative. So I'm going to do that. So log base 3, and then we're going to go 3 to the negative 1 power. Did we create the opportunity to have that log base 3 of 3 going on? Yeah, and what happens with that? Cancels. Now, we got to be a little bit careful this time because I've got that 6 in front. So the 6 drops down, and this becomes multiplication. So what's 6 times negative 1? Negative 6. And there's going to be another, starting, I think, Tuesday, where there's going to be another way we manipulate that exponent, too, that's ended up there. Any questions on that one? Okay. All right, let's look at the next one here. Okay. All right, so this is one we haven't seen it yet. This is the first time we've seen it in the notes. I'm going to scroll up. So you stay there, but I'm going to scroll up to that little box that we had. Maybe. I made it super big here. All right, it's this one, right? It's this property right here, which is just the backwards of what we've been doing, right? If I have the number log, and of the base is the same number, they cancel out, and I just get whatever's left behind. All right? So as I'm scrolling, do the canceling, right? All right, we've got log base 9 to the log base 9 of 24. What happens? What cancels? 9 and log 9. What's left behind? 24. Perfect. Okay. Looking at example 20 here. Okay. Do I have anything that cancels yet? Could I create it?
Yes.
How could I create it? Is there another name for 4? 2 squared. This unit is going to be about a new way to look at exponents, basically. So you're thinking exponents when we're talking about rewriting a number. Okay. All right. What happens with log base 2, 2? Cancel. So I've got 1/2 times 2. What happens with 1/2 and 2? They cancel. So what's my answer? 1. All right. These last ones kind of snuck on there as properties, but they're good because they look a little bit weird. These we're going to rewrite in exponential form again. So these are back to the red square problems like we were doing at the beginning. Okay. All right. I don't know why they're not at the beginning. Apparently, I was not paying attention when I rewrote the notes here. So let's see if we remember what we did at the very beginning of the lesson. So what is the base on example 21 there? 4. And then what am I supposed to do with the 1 and the 0? Switch them. I'm looping it around, right? I'm log looping. I'm looping the spots. So 0 equals 1. Is that true?
Yes.
Is 4 to the 0 equal to 1? All right. Everybody do 22. Anything to the 0 power is 1, right? All right. Everybody do 22 really quick. All right. What's your base on 22? 5. What's my new exponent? 2 equals 25. Perfect. Oh, I've got 2 more there. All right, try 23 and 24 on your own. See if you can get them. I know, and 24 looks weird, right? You're going to loop, though. You're not going to use the canceling out thing. So loop it. Loop both of those. We're not canceling this time, you're looping. Okay, check in with somebody at your table. All right, on 23, what's the base? 6, and I'm going to loop this around. What's my new exponent? Equals?
216.
Good. All right, on 24, what's the base? Square root of 7. What's my new exponent? Equals? Yeah. So we can't be scared of what's there, right? It might look weird sometimes. It's not a big deal. Okay? All right. I think that's it, right? Yeah, okay. I know you don't have the learning log page yet, but that's okay. We don't need it right now. Okay. I'm gonna assign you some homework on it. I have not done that yet. We need to do our skills check quiz. Okay. So I'm gonna you have about a 5-minute breather, okay, because I haven't assigned the quiz yet, so I need a few minutes to do that. So you have a 5-minute mental break. We'll do the quiz at 11:25. Okay.